be blood.
Well, why am I here?
Welcome. The door is locked, and there is no way out of this room. You will be in that room for your entire life until you solve those questions on that piece of paper. Write down the answers to the problem on the paper. If your answer is correct, the door locks will be removed, and eventually you can get out of this room. Good luck.
Is this a problem that I've learned in Mr. Nichols' calculus class?
Since the integral of x is x squared over 2, the integral of sine x is cosine x, the answer to this problem is x squared over 2 plus cosine x plus c.
How to do this?
Hi class, today I'm going to teach you guys about how to solve very complicated integral problems by using the technique called U substitution. And this method really helps you to solve the complicated integral problems, and by using two different equations and using U, you can simplify the equation and solve it like a simple integral equation. So I'll show you an example of an integral problem where you can use a U substitution. This equation you can't really simply integral by parts like this and this, unlike the equation like this, because you can actually integrate part of this and part of this when you try to solve a integral of this. So the first step you do is to differentiate this equation, which becomes du equals 2x dx. See, dx and dx matches here together, so I'm trying to solve for dx. So dx equals 2 du over 2x. So I'm going to substitute this dx into this dx so we can make the equation simple. So the equation becomes like this. When you plug the dx there into this, x squared plus 1 times du 2x. So the x get cancelled and it becomes a simple equation where this becomes u, where I substitute it here. So the equation becomes 1/2 times u du. So I'm going to integrate u here, which becomes u squared over 2, and like where I said u here is x squared plus 1. So x squared plus 1 squared over 2 times 1/2. So the answer of this problem becomes 1/4 x squared plus 1 squared plus c. Yep. There.
To find the integral of e to the 4x, I cannot just integrate it. Here, I will use u substitution to solve this. I will make u equals to 4x. Next, I need to find du, which is the derivative of 4x, which is 4 times dx. Then, I will solve it for dx, which is 1 over 4 times du. Now I'm going to replace 4x with the variable u. And I'm going to replace dx with 1 over 4 times du. Now, I'll find the integral of e to the u. which is also e to the u. Then the last step is replace u with the 4x. So the answer is 1 over 4 times e to the 4x plus c. Okay, for this problem, I also cannot just integrate it. I noticed that 2x is a derivative of I squared, so I'm gonna use u substitution to solve this problem. First, I set u equal to I squared. Next, I need to find du, which is the derivative of I squared, which is 2x times dx. Now I'm gonna replace I squared with u, and 2x dx with du. So now, I need to find the integral of cosine u, which is sine u. Then, I replace u with x squared. Hence, the final answer is gonna be sine x squared plus c. This problem cannot be solved in normal way too. I realize that I have the expression x cubed plus 4, and I also have a part of its derivative, which is I squared up there. This is a big clue for me to use u substitution. So, I'm gonna set u equal to x cubed plus 4. Then I will find du, which is the derivative of x cubed plus 4, which is 2x squared times dx. Next, I need to find what is the value of x squared dx in terms of du. The answer for this is 1 over 2 times du. Now I can rewrite the integral. So now I have 1 over 2 times the integral of du over u. That's going to be equal to 1 over 2 times ln of the absolute value of u. Hence, I am left with 1 over 2 times ln of the absolute value of x cubed plus 4 and plus c. That is the final answer for this problem.
Good job. The door's gonna be open now. You can leave.